One of the interesting things about working with Lehr Gardens is all of the strange and unexpected things that it does. And of those, probably the strangest and most unexpected is its production of a product called Lehr Soil Amplifier. Welcome to the Lehr Innovations page. My name is Edmund Williams, and today we're going to be talking about Lehr Soil Amplifier. Now, this is a particularly large topic, so I'm going to break this up into several individual videos. Today I'm going to be talking about where it comes from and what it is, and a little bit about what's in it. So when I first started creating my first Lehr garden back in 2013, I wanted to see if I could create an aquaponics system with living soil. I didn't like the way that aquaponics removed the soil from the system, and I wanted to see how it worked with living soil. And of course, if you want to create living soil, you have to feed it. So that includes a lot of organic matter, and in this case, particularly a lot of wood chips. And so wood chips are a very complex carbohydrate. Literally, they're chained up sugar molecules is a big portion of what's in there, and so it's a long-lasting food source for a lot of different soil organisms. And it actually worked better than I thought it would be. So the first year I had a bed. I got an aquaponics tray that was 4 feet by 8 feet and 6 inches deep, and I filled that guy up and I planted it, and everything grew really, really well. I was very impressed. And the second year it failed. And it was really easy to see why it failed. It didn't fail completely, it just struggled. But it was really easy to see why. As those organic matter components broke down, they became a little bit more silty. They had smaller particle size. The Lehr garden at its core is a flood and drain system, and so the water was no longer flowing through. It was being held in place. If you hold water in place where there's a lot of high organic matter, then it tends to go anaerobic, and so the plants don't like to grow in anaerobic soil. And so my thinking was I needed better drainage, so I got some grow bags that got me up to 9 inches deep, and it worked really well the first year, and it failed the second year. And then I went and I built a garden bed, redesigned the system, built a garden bed that was a foot deep, worked really well the first year, failed the second year. So I went to 1.5 feet deep, did the same thing. I was actually in the process of building one that was 2 feet deep when I realized I was maybe on the wrong track, because what was happening was it didn't really seem to matter how deep it was. That soil was becoming compacted, it was becoming anaerobic. And I tried a lot of different things to see if I could fix that problem. I tried taking out some of the soil and replacing it, just refreshing it with new wood chips, and it didn't remove enough of the fine particulates that it solved the problem. I tried putting in a higher content of inorganic matter using soil and sand and various components there, and that actually just accelerated the compaction problem. It didn't work. So it was after a lot of experimentation that I realized maybe what I needed to do was actually just take out that fine particulate matter. The first experiment that I did with that was I actually just used a water extraction method. So I took a 5-gallon bucket and a colander, threw a bunch of soil in, swished it up, assuming that the fine particulate matter would remain briefly in suspension, and the water pulled the sieve out, and then I was just dumping the water around the yard, just trying to get rid of it. It needed to be out of my garden. And that was actually where I got one of my first really surprising results, because at the time I was living in a rental where I was required to water a garden, water grass, sorry, and the grass wasn't doing well. I wasn't required to fertilize it, and I don't really think grass belongs here in the desert in the Phoenix area. So it was the middle of summer, and I had a large area of dead grass. And so I took these buckets of water and I dumped them in a huge dead rectangle of grass. I poured an LEHR in about 15-foot high letters across the front yard, thinking, in a couple of weeks that the grass that was exposed to this was going to bounce back, and I would have something that I could use as marketing materials and say, hey, this stuff works great on your lawn. It didn't work. What actually happened was my lawn exploded into green growth. for the entire lawn. It was actually, I mean, things that were 15, 20 feet away from where I poured anything, all of a sudden turned green and started growing and became really healthy and robust. And so that was one of the first really solid indications that I had something unusual on my table. And so I then realized that sifting was going to be a better option. The wet method was messy and it was slow and it was really, really inefficient. So I went and I built myself a sifter. And one of the things that was really interesting that happened when I sifted the soil was there's another property of the soil that comes out of a Lehr garden when you've run it for over a year, closer to a year and a half. There's a property, there's a method of composting called a Johnson-Su bioreactor, and it's a method where they use the structure of the bioreactor to passively aerate the compost without actually turning it. And one of the properties, and they run it for a very long time. It creates a fungally dominated compost, which I'll get into that in a different video. But one of the properties they say is that if you take compost and you put it in your hand and you squeeze it, it's gonna be kind of spongy. It'll bounce back. It's basically non-moldable, non-compressible for the most part. But if you take this stuff that comes out of a Johnson-Su bioreactor and you squeeze it between your fingers, squeeze it in your hand. It'll squeeze out between your fingers like clay does. And the same thing happens with Lehr soil amplifier. When you take it out of, when it's a little overcooked, it'll certainly do that. And I've had that happen a number of times. But the part that's really interesting, I noticed this when I first started sifting it. I took this product that was squishy and it was clay and it was very formable and moldable, and I dried it out and I sifted it, and then I took it back. Now, of course, the stuff that I sifted out was the larger particles. The wood chips weren't as broken down, and when I took those out, it should be more clay. But I dried it out, I sifted it, and then I rehydrated it to see if I could turn it back into that clay moldable form, and it doesn't actually reform back into that clay material. Something happens with the structure of it where it doesn't reform into that moldable product. And I don't know why that happens. I don't even have a reasonable theory as to why that happens, but it's certainly an interesting result, probably worth looking into. Which of course brings me to the topic of, this is something that I've actually spent about the last 3 years doing research on Lehr soil amplifier and trying to understand what's in it and what it does. There's a ton more research that needs to be done, but here's what I can tell you so far. Lehr soil amplifier is a product unlike any other compost type product out there. It is not completely unusual in that it is created in a form similar to what we've got under exceptionally healthy ecosystems in the soil. It's created in place by the plants, but it's really not, when you do that, it's not harvestable, and it's because first of all, it's very difficult to separate from the inorganic matter of the soil. So typically the inorganic matter of the soil is going to be, probably in the neighborhood of 75 to 95% of the soil structure. Really, the organic matter itself is going to be about 5% in most cases. So it's something that's very difficult to separate from the inorganic particles. It's something that takes a very long time to make, and when you do, it's destroyed. But in a Lehr garden, we're actually creating it in about a year, 9 months to a year typically. And when you do that, it has to be harvested. So it's actually creating harvestable soil from something that's normally not considered harvestable. So as I've looked into what's in the soil amplifier, a couple of things became really, really obvious. The first is that there's two qualities that the soil amplifier has that are unusual. The first is that soil amplifier, and this is actually unique among compost products. So soil amplifier is actually the only compost product that's created under the roots of living plants. So what happens with soil is that if you take compost, decaying organic matter, that's what's called labile soil carbon. What makes, now the labile soil carbon typically breaks down, it's somewhere between the carbon that's in that material is broken down typically between 99 and 100% by the soil organisms. There is some material out there that maybe a very, very tiny percentage of it is actually turned into stable soil carbon. That's one of the theories as to where humic acid comes from. But generally speaking, that conversion rate is phenomenally tiny. So stable soil carbon, which is the stuff that makes up topsoil. So topsoil, the difference between soil and topsoil is a component of soil carbon called stable soil carbon. Makes up typically up to about 5%. If you've got 5% stable soil carbon, your soil is actually really, really good stuff. So it's very effective in very small amounts. But the stable soil carbon is made by the plants themselves. So the way that works is if you take the labile soil carbon, that's food for those soil microorganisms, and those soil organisms are going to eat that carbonaceous material. They're going to decompose it, they're going to break it down, they're going to turn it back into carbon dioxide. In an ideal situation, under the leaves of living plants, where those plants can absorb the carbon dioxide that's being released and reuse it as a food source for themselves. But they release that carbon dioxide, and in doing so, they're helping the processes in the soil that are going to feed the plants and help the plants be healthier. So the soil organisms are ultimately taking care of the plants themselves. And then what happens is the healthier plants grow a healthier root system. They're going to grow bigger. They're going to drop more material, which is going to help the soil. It's kind of a loop that way. But also what happens is the plants produce what are called root exudates, and they're pumping compounds into the soil, and they're very targeted. It's something that we don't know a ton about, but there is certainly some science around it, and it's something that's been a larger area of study for science recently, as we're trying to really understand some of the interactions. But what ends up happening is the plants themselves are changing the chemistry and the biology of the soil that they're growing in into what they need to best grow. And so that changing of the soil, that's what creates topsoil. And typically the argument is that topsoil takes about 100 years to create an inch of topsoil. I've heard up to 1,000. I'm not sure that anybody's ever really done the research on that, but it does take a very long time to create those compounds and create those biological networks that actually make up topsoil. And if we want to grow food, topsoil is the best stuff there is. So what Lehr Soil Amplifier is that it's actually the only compost product that's produced, like I said, under the roots of living plants. So all of those products that are happening through those root exudates are going to be active in the final product that we take out of the soil. The second area where it's unique, and I want to say again that we're the only ones that are doing that. That's the only product that I've ever heard of where those product of the root exudates are in a form that is sustainably harvested and can be sold on the open market. The second piece of that is something that we share, again, back to the Johnson-Su bioreactor, which is something I'm going to cover in a different video. But the Johnson-Su bioreactor creates what's called a fungally dominated compost. And that fungal domination is something that turns out to be very, very powerful. It creates different microorganisms, and what they found is that that fungal domination creates a compost that's as effective in as little as 2 pounds per acre. And so if 2 pounds of soil is about a softball size amount of soil. It's less than a gallon, maybe 2/3 of a gallon. And they spread that out on an acre. And the results are described as phenomenal. Now, the fungal domination is achieved by not turning the compost. A Lehr garden is also not turned, and I have tested for the fungal domination, and we do have a fungally dominated compost in about the same area as a Johnson-Su bioreactor. So those two parts are definitely there, which brings me to the next piece. The appropriate classification, again, as I've done my research and really dug into this, Lehr Soil Amplifier isn't a compost. I call it a compost product because it is created through composting methods. And just so you know, what I kind of struggle a little bit, is a little bit of a forewarning between like what I call it, because when my plants are growing in it, it's my soil that the plants are growing in, and when I'm harvesting it, it's using composting methods. So I also kind of tend to call it compost, but ultimately, what it is most effectively, the correct terminology is it's a biostimulant. And that's one of those things where I think there's a lot of research that needs to be done. Biostimulants are products that there's not really a comprehensive list out there of what constitutes a biostimulant. There are a number of things that they have said, yes, this definitely is a biostimulant. So first of all, what is a biostimulant? A biostimulant is a product that when you add it to the soil, it's not necessarily going to transfer nutrients to the soil, even though Lehr Soil Amplifier is loaded with nutrients, especially micronutrients. But a biostimulant encourages the healthy soil organisms to reproduce and proliferate and become healthier. So it's something that typically seems to work in very small amounts. Sometimes it's adding those soil organisms that are needed. Some other times it's more of something that's chemical, that's going to be creating the right conditions for the soil organisms to flourish. But I think that's actually why the Johnson-Su compost is really better classified as a biostimulant, is because it's so effective in such tiny amounts, and that's really the classification where the Lehr Soil Amplifier is. So so far I've identified 7 different kinds of biostimulant that are like things that are known to be biostimulant that are in the Lehr Soil Amplifier. So the first, like I said, is those products of the root exudates. That's certainly something that's a very powerful biostimulant. The second, of course, is the fungal to bacterial ratio. The third one is going to be earthworm castings. So earthworm castings are basically when you have earthworm activity, they're poop. I'm just going to call it poop. Castings is the kinder way of saying it. But as they digest the material, they have a tendency to not only form the structure of the soil, but they also encourage the really beneficial soil organisms in their gut, and they will create they create amazing soil. I mean, it's another one that's typically added in fairly small amounts because it is more of a soil conditioner, a biostimulant, than it is just a bulk soil product. The next one is a product called glomalin, and I'm going to talk a little bit more about glomalin in a separate video. It deserves its own video, but it is a soil glue. It's actually a subset of those root exudates, but it deserves its own category. And it's something that really is extraordinary for creating topsoil. It's actually, if you look at the carbon content, it's about a third of the carbon content. Then you have the mycorrhizal fungus. Mycorrhizal fungus is a fungus that is symbiotic with plants. It's sort of like a living fertilizer, and we know the mycorrhizal fungus are very active because of the presence of the glomalin. It's actually only made by mycorrhizal fungus, and so by having that there, we know that it's present. And then on top of that, what the mycorrhizal fungus does is that it'll actually produce spores. Some of them actually produce little mushrooms, but all of them will actually produce spores along the length of their hyphae, which are the strands that make up their body. They'll produce these spores and they'll load the soil with them. And so the Lehr soil amplifier that we harvest is actually going to be also a mycorrhizal inoculation. The next one is going to be humic acid, and humic acid is a product. It's the second largest component of soil, of the stable soil carbon, and it's something that again deserves its own video. I've got a lot of questions and a couple of answers, and we'll definitely be talking about that. I'm not an expert on it yet, but I've learned enough to know that I'm very curious about it. And the last one is biochar. Now there's some debate out there about whether biochar is a biostimulant. There's some people that say that it absolutely is, and there's some people that say that really it's kind of not. But what biochar does is that it stimulates, it helps the soil bacteria thrive and prosper. It actually acts to absorb nutrients and hold the nutrients in a way that the soil organisms can get to them easily. It holds water. There's a whole bunch of different things that it does. It's a fantastic soil conditioner, and we know, of course, that the biochar is in there because we are adding it ourselves, and actually the whole process of the soil creation concentrates the biochar. So when we were creating the soil, it's about 5%. We inoculate it with about 5% biochar, and then when we harvest it, we're getting more like 25% biochar. So I'm going to go ahead and stop it there. We're over 20 minutes, but stay tuned. I'm going to be digging into a little bit more about a couple of those components because they deserve their own video. But then we're going to talk about ways in which this actually helps the greater urban agriculture ecosystem and actually agriculture in general. It's got a lot of potential. And then on top of that, we're just currently in the process of hiring a soil scientist so that he can help us better classify this product. So I would like to have, report back with some of the findings that we get from that, and if I can manage it, I would love to have him on here and where we can talk about the Lehr soil amplifier and what it means.